The last session we have discussed what in by the armature reaction, then what are the different axes what you are marked for analysis of the armature reaction. Once again, then we will recap those things and we will move forward. That is, we know that is the effect of the armature flux on the main magnetic flux is called as the armature reaction, and it has got two effect. One is the demagnetizing effect, the other one is the cross magnetizing effect. And also we are defined the polar axis, that is which is the line which is joining center of N pole to center of S pole. At the same time, the geometrical neutral axis, that is GNE, which is defined as which is the line perpendicular to polar axis. Then the magnetic neutral axis in general, that you have to keep in your mind, that it is axis which is perpendicular to lines of magnetic flux. Lines of the magnetic flux. It may be defined as the axis along which no EMF is induced, or in the armature conductor because they move parallel to the lines of flux, or MNA is axis which is perpendicular to flux passing through the armature. What I mean, that is the polar axis joining between N and S pole, the geometrical neutral axis which is perpendicular to the polar axis. The magnetic neutral axis is nothing but it is axis perpendicular to lines of flux. The same thing we are marked here, that is the first one is the polar axis which is joining N and S, and the second one we are defining the geometrical neutral axis which is perpendicular to the polar axis. Okay. Now we have a magnetic neutral axis, may be defined as the axis along which no EMF is induced, or it is defined as it is a line which is perpendicular to the magnetic flux. That we will define now. Then usually the brushes are always placed on the magnetic neutral axis. That is, the brushes were placing on the magnetic neutral axis. Then also we have seen that we are considering two different cases. One, only if you are exciting the field axis, there is no current in the armature current, then there is a flux is produced, that is represented by OFM. It is the armature, the magnetic flux is produced because of the magnetic field winding movement on the N and S pole. Therefore, they are producing the magnetic flux. This flux is known as the main flux. This flux is known as main flux. Now, in the first case, I am considering here there is no current is flowing in the armature conductors. This main flux is represented by OFM. Therefore, it is OFM. Therefore, your magnetic neutral axis is perpendicular to this main flux. Therefore, in this particular case, the geometrical neutral axis as well as the magnetic neutral axis, they are coinciding each other because the MNA is perpendicular to OFM, where GNA is perpendicular to polar axis. Okay. Here I am shown here only the main flux. There is no armature current in the armature conductors. The second case, what I am considering, there is no main flux, means the field winding of the poles are not excited. However, the armature, there is a flow of current in the armature conductors. Therefore, the field or a flux set up by the armature conductors alone, when the carrying current, the field coils be unexcited. There is no flow of current in the field winding, only there is a current in the armature flux. Therefore, here I have what? There is a current in the armature conductors, but however the main fields are not excited. Then whenever there is a current is flowing in the armature conductor, it is producing its own magnetic flux, that is represented by OFA. That is, it is FA. This FA is the flux produced by the armature. Flux produced by the armature conductor. It is this FA. Thus, I am addressing this. FA is acting along the magnetic neutral axis. It is always acting along the magnetic neutral axis. Okay. Now, in actual generator, we have what? Both the main flux as well as armature flux they are existing. In actual case, here what I am considering is one at a time, but however in actual practice, when the generator is operating, in that case, both main flux as well as the armature flux they are existing. The generator that I am showing here. Okay. Here I have got a main flux once again, and it is in this case this is a main flux. Therefore, perpendicular to main flux there is a MNA. GNA is defined as it is perpendicular to the polar axis. Then the main flux is represented by Fm. Now I have got there is a I told you there is a flux is produced by the main flux because of the there is a current is flowing in the main field. Then there is a main flux, but at the same time generator is loaded, therefore current is flowing in the armature conductors. Therefore there is a flux is produced by the this armature current that is represented by here. These are the flux which is produced by the armature current. Therefore, the direction of the flux is exactly it is along the magnetic neutral axis. What I am calling is Fa. Now, there are two fluxes they are acting simultaneously. One is Fm, the another one is Fa. Then, what is the resultant flux in the air gap? What is the resultant flux in the air gap? Because of the resultant flux, there is the magnitude of induced EMF and the availability of the voltage across the terminals of the load you are getting. Therefore, what I am interested is because of this main flux and the armature flux, there is a resultant flux is producing. What is the magnitude and the direction of that resultant flux? I am interested. Therefore, what you have to do? You have to add vectorially Fa and Fm so that I am getting the resultant flux. Okay. Therefore, what I am getting is the resultant flux F. Then I told you that the magnetic neutral axis is always perpendicular to the flux. Now, the flux no longer acting down here Fm, but it is acting making some angle and it is changing its little bit of a direction and its magnitude also the changing because the resultant flux is because of the vector sum of Fa and Fm. Therefore, what I am getting is here is the resultant flux F. Therefore, its magnitude is also changed. At the same time, the direction is also changed. Now, the magnetic neutral axis no longer is which is perpendicular to polar axis, but it is should be perpendicular to resultant flux. Now there is a new magnetic neutral axis. Then there is shift of magnetic neutral axis because of armature flux. If there is no armature flux, and that is MNA and GNA the coincidence. Whenever there is the existence of FA, then there is a shift of the magnetic neutral axis, which is perpendicular to resultant flux. The same thing is written here, vector OFM which represents the both magnitude and direction, the MMF producing the main flux. The armature flux MMF is shown separately both in magnitude and direction by the vector OFA, that is this OFM is main flux, OFA is the armature flux. Under actual load condition, there are two fluxes they are acting, one is Fm, another one is Fa. Same thing is written. Under actual load conditions, the two MMF existing simultaneously in the generator, it's seen that the flux through the armature is no longer uniform and symmetrical about the pole axis, rather than it has been distorted. It has been distorted. What do you mean by distortion? What do you mean by it is not symmetrical? That we will see now. Now, I am shifting the magnetic neutral axis along the new MNA. This is GNA because it is perpendicular to polar axis. I have got main flux here down by the flux, and Fa is because of armature flux. The first case what I am considering here, it is F. because of this resultant flux there is a new MNA. Therefore, I am drawing here new MNA which is parallel to this. Actually, this is your new MNA because the resultant flux is producing. The MNA is perpendicular to main flux. Therefore, now I am having there is shift of the brushes along the new MNA. I told you that is brushes always placed along the magnetic neutral axis. If there is a change in the direction of the magnetic neutral axis, our brush position is also changing along the new MNA. Therefore, we have got to brush out this MNA. Now we can see here because of this flux, no way it is the perpendicular to geometrical neutral, so that is the main flux, but the main flux is changing its direction because of this armature flux. Therefore, there is a bulging of the lines of forces of the magnetic flux. That is because of this armature flux. Therefore, there is a distortion in the main flux. If there is no armature flux, there is a straight away they have got a main flux is acting downwards. Because of the armature flux, there is a distortion of the main flux. Then what is the effect of this? That we'll see in the next slide. The effect is that we can see here. Here it is the most of the fluxes they are concentrating on this, and there is a weakening of the flux in this particular pole tip. If the rotor is rotating in the clockwise direction, that is, if the rotor is come in contact with a pole, that is the first time, that is called as the leading pole tip. This is called as a leading pole tip. This is called as trailing pole tip. It is a leading and it is a trailing pole tip. That is how we are making. This is a trailing pole tip. That is we are rotating in the clockwise direction. Therefore, there is a more number of lines of force are concentrated on trailing pole tip, whereas there is a weakening of the flux nearer to the leading pole tip. This is the effect of the armature flux on the main flux. Okay, the flux which is seen crowded at the trailing pole tip. Okay, it is crowded here, but at the same time it is weakened on the thinner out at the leading pole tips. Okay, the pole tip which is first batted during the rotation by armature conductor is known as leading pole tip, and the other as a trailing pole tip that I defined. Therefore, you can see here now this is GNA which is perpendicular to polar axis. Now I have got FM, FA because of armature flux FA and this FM. There is a resultant flux. Because of this, there is a new MNA. The same thing, that is what a previous figure what I shown. Then the brush axis is now along the new MNA. Then there is a distortion of the main flux. That is a distortion of the main flux. Then what is the effect of this? Because of the new MNA, that is the magnetic neutral axis, is shifting with angle theta because of this armature flux. Because of this armature flux. Then what is the effect of this changing of new MNA that we'll see now? In the figure shown, the resultant flux OF, that is the resultant flux OF, which is found by vectorially combination of OFM and OFA, that is main flux and the armature flux, and new portion of MNA which is always perpendicular to resultant flux, that is new MNA should be perpendicular to the resultant flux. With the shift of MNA straight through an angle of theta, that is now MNA is shifted by an angle of theta with the original portion or GNA. Through an angle theta, brushes are also shifted so that lie along the new portion of MNA. Due to this brush shift, the armature conductors and hence armature current is redistributed. Because of this shifting of the MNA, there is a redistribution of the the current in these conductors, because they are not holds the same direction in this particular set of conductors. They are some of the conductors, they are changing the current direction in their conductors. That we will see now. All the conductors to the left of the new position of MNA, but between the two brushes, they carry the, the current downwards. What is telling that? That is a with the left of new MNA, left of new MNA, and along up to the brush axis, up to the brush axis, they carry the current in the downward direction. However, those to the right carry the current upwards. That is the conductors which is along this, they are carrying the current in the upward direction. This is the current is carrying the upwards here. Then the current, these conductors are carrying the current in the downward direction. The armature MMF is MF is found to lie in the direction of the new position of MNA. I told you the armature MF is always acting along the new MNA. What is that effect? That we will see first. The armature MMF is found to lie in the direction of new position of MNA. I told you that is the armature flux is acting along the magnetic neutral axis. Now there is a change in the magnetic neutral axis, therefore the OFA is also changing its direction along the new MNA. Same thing I have shown here. That is first GNA, which is perpendicular to polar axis, new MNA, then along the new MNA we have got a brush axis, then it is shifting an angle of theta. Now there is a redistribution of the current in this particular direction. Now FA is acting along the new MNA. Therefore, now it is acting along the new MNA. Therefore, what I mean is, I have got a FA is changing its direction. Then it has to, if we are resolving along the polar axis as well as the GNA, it has got two components. FA is resolving along the polar axis as well as along the geometrical neutral axis. Then what we are getting is the two component. One is FC, which is along the GNA. Then another one is FD, which is along the polar axis. Then you have got two component of FE. That is, one is FC, which has got this component is called as the cross magnetizing the component, whereas FD is called as demagnetizing, because FD is opposing the main flux. FD is opposing the main flux, and FC is distorting the direction of the magnetic flux. Therefore, this is called as cross magnetizing component. This is called as the demagnetizing component. The same thing is explained here. The OF can now be resolved into two rectangular components, OFD parallel to the polar axis and OFC perpendicular to this axis. We find that the component OFC is at right angles to the vector OFD. It produces distortion of main flux. OFC is making this distortion because the main flux is acting in this direction. Therefore, FC is in this direction. Therefore, it is distorting. Then the FD, the main flux is from the downwards. That is, if we are marking here, then FD is exactly opposite to the main flux. Therefore, the FD is called as the demagnetizing component. Okay, in the next session we will derive the equation for what are the cross magnetizing ampere turns and demagnetizing ampere turns.